Hey everyone, we'll go ahead and get started now. It looks like we have quite a few people joining us so far, and I'm sure more folks will trickle in. But without further ado, everyone who hasn't in the chat already, it'd be awesome if you could go ahead and share with us where you're joining us from today. I'm Julia, and I'm from the Springboard team hosting here at our office in San Francisco. And joining me today is Danny Wells, a data science professional and one of our data science mentors here at Springboard. Where are you joining us from today, Danny?
I'm based in San Francisco. I'm also like Springboard. I'm currently in the office at the Parker Institute for Cancer Immunotherapy, where I work as the senior data scientist.
Awesome. Thanks so much for sharing that. And so if you'd like, do you want to share a little bit more about your role at the Parker Institute and sort of what you do as your day-to-day there as a data scientist?
Yeah, definitely. So as I mentioned, I'm the senior data scientist at the Parker Institute for Cancer Immunotherapy. I've been here for just about 3 years. We're a pretty new institute. We work at the intersection of cancer biology and immunotherapy and immunology and then big data, trying to build large data sets from patients who are enrolled on our clinical trials and helping understand and analyze those data to help understand who's responding to which treatments and why. In my role as a data scientist, I do all the usual things that data scientists do. I build pipelines to process big data. We have over 100 terabytes of data, so there's a lot of processing to do. I develop machine learning algorithms to be able to predict, which patients are responding, and then further use those methods to kind of identify the characteristics of the people who are responding, and then we use those to help hopefully inform new trials and new pieces of science. So it's a full stack data science job, kind of from end to end, from raw data to visualizations and everything after.
Wow, that sounds like a lot of responsibility to have, but also something that could be really fun.
Yeah, it's a lot of fun.
Awesome. Well, it looks like we have some more people joining. So let's go ahead and get started. We have a lot to cover today. So as I mentioned a little bit earlier, feel free to submit your questions in the chat or in the Q&A as well, so we can go ahead and incorporate them into our conversation today. But to kick things off, so today we're going to be talking about data science portfolios and why they're important and how to build one that really sets it out against everyone else's. So Danny, it'd be awesome to start off by sharing why it's important to have a data science portfolio and what purpose does it serve?
Yeah, absolutely. So the way that data science is right now, it's definitely the case that you need to have a core skill set composed of, a deep knowledge of statistics and machine learning and programming skills, but there's also kind of this like je ne sais quoi, this kind of piece to being a data scientist where people are just looking for a person who can use data to solve their problems, right? They will say, I don't know, exactly what's wrong, but I know that data could probably fix it. And so a data science portfolio is really your chance to show how you can identify an important question, how you can find the data for that important question, how you can analyze that data to ultimately make an actionable recommendation that's really going to have an impact on the business or the place that the people you're doing this analysis for. And that's really the skill that we at the Parker Institute, when we're hiring, and really probably all across, all around when they're hiring for data scientists, they're looking for people who can go end to end on a particular problem where they start with a question, and then they're able to end with a recommendation.
Very cool. Thank you for sharing all of that. I know that's one thing that some of our students really try to make the most out of, because they begin to realize how valuable having a portfolio is, to be able to showcase your skills and your experience and be able to say, hey, I've done this and I can provide this kind of value to you and your organization.
Mm-hmm. Mm-hmm.
And so, are there any optimal formats to showcase your portfolio in, or places
Mm-hmm.
to host your code, things like that? What would you recommend?
Yeah, absolutely. So my personal belief is that the absolute kind of best way, well, perhaps there's a couple of ways you can imagine showcasing a project for your portfolio that's really going to stand out. I think the first and kind of the most classic way to do this is in a GitHub repo. GitHub, for those who don't know, is an online code storage solution where you're able to push your code up there, and this code can be viewed and shared with other people. But there's many, many features that make GitHub a really good place to showcase your data science portfolio. One of them is that it has full support for a type of document called a markdown, and so you're able to, write up your final kind of summary of your project and everything you did. You can include figures and plots and tables and all of that, and that can live directly with your code. And you can actually link directly to your code. So you can say, yep, I ran, this particular method to build this machine learning predictor, and this is what I got. And then the person who's reading it, who's potentially interested in you as a candidate for a role, can be like, oh, that's interesting. How exactly did you do this? And they'll be able to go, right to the code and be able to be, oh yeah, that was really smart. That was, the right way. And I'm really happy to see that you're able to use that tool set. So when I see a candidate who has a really strong GitHub repo with, one or ideally two or more, strong projects that show their ability to summarize their projects and make good figures and build good predictors, and then I can go see their code, it's a very, very strong point for that person. The other way, and it's a little bit more advanced, but I always like to recommend this to students, is I'm actually a big fan of building a website as well. In the modern day, now we have things like Squarespace and these other tools, and these make it really easy to kind of encapsulate all of you. And so what's nice about a website is you can do more than just your portfolio project. You can have kind of a summary of who you are and include your resume and maybe travel pictures from your recent travel or pictures of your dog or things like this. But websites also really, really stand out, especially when you use a professional tool and you put a lot of time into it. And then I say, okay, this is someone who really sees themselves and their abilities in a singular way. And kind of as I mentioned before, that's often what companies are looking for. They're looking for someone who says, I am unique and I'm a unique asset to your team, and I'll be able to uniquely identify problems across your organization and solve them with data. So those are kind of the two ways that I think about it.
Awesome. And sort of building off of that, we just got a question in the chat from Emmanuel, who is asking, is there value in blogging about projects that you work on to have alongside what it is that you are showcasing in your portfolio?
Yeah, absolutely. And maybe that's what I would say is number 3. So something like a set of Medium posts or even your own blog, I think is really, really powerful. And even, many years ago when I was kind of building up my first portfolio, I treated it closer to a blog than a set of projects. I would find a data set that I was interested in and kind of analyze it and create some figures and then just kind of write about my thoughts about it. So it was not quite as formal, but I did it a little bit more consistently, and I ended up building up, 5 or 7 little blog posts. And these were really nice, and they gave people a way to kind of get an insight into how I worked. It's important too to also have kind of big pieces of work that really show your ability to go end to end. So I wouldn't say it's a replacement, but I think it can be a very strong supplement.
Okay, awesome. And also kind of along those lines with sort of picking what types of projects to put in your portfolio or to include, is there any sort of guideline in terms of like breadth or depth into projects for including or having different types of projects?
Yeah, that's a really good question. So I think that there's a couple of ways to think about it, but I think it's really important to have at least, so there's many, many different machine learning and data science tools out there, and you can think of things like natural language processing or deep learning or all of these. I think there's a core data science skill set that's really, really important to demonstrate your ability to kind of use end-to-end. And the way that I think about this is to have a project that encapsulates, all in one place, your ability to ask a good question, to find a data set that can help you answer that question, to show that you can clean that data and get rid of all the stuff that's inside of it, because we all know that most data sets are very, very messy, that show your ability to make plots and to kind of quantify the results you see in those plots using statistics, and then ultimately to be able to apply basic machine learning, something like logistic regression or a support vector machine, to build like a basic predictor of that data. This doesn't have to be something that's perfect, but just something to kind of show your ability to use those machine learning tools, and then especially to kind of be able to analyze and show how potentially, okay, yep, I built a predictor, but it still has some errors, and then these are the ways that I would improve. Those are the skills as a data scientist. You will use that pipeline end to end over and over and over, and you may layer on extra things. You may say, I have 100 million images and I want to build a deep learning classifier. Okay, or, oh, I'm working primarily with text data, so I need to build something like a TF-IDF matrix. Okay, but that kind of core ability to go end to end from a question to ultimately providing a result and a summary of what you learned, really, having one portfolio project that really encapsulates that is pretty important.
Good to know. Thank you for sharing about all of that. And now, how many different types of projects should someone include in their portfolio? Does it make a big difference having, let's say, like 6 projects to showcase, or just 2 or 3 really awesome ones?
Yeah, so when you're looking for a data scientist role, to me, quality is much, much more important than quantity. We've seen people apply to the Parker Institute, and when I've been helping with other recruiting jobs as well, where they had one truly exceptional standout piece of work. I mean, the stuff, it's like tears in our eyes type of stuff. And we were all clamoring, and these people ended up getting jobs from job offers from everywhere. And I think that's, yeah. So it's much, much better to do a really, really bang up job on 1 or 2 projects than it is to kind of do a bunch of little things and 6 or 7 kind of tinier projects. I think if you can do both, that's obviously ideal, when you can show that you're able to do quick work and deep work. But of course, time is limited, and all of us are trying to get as much done as we can. So if you have a choice, I would always go to the quality side. But it's good to have a balance too.
Awesome. Good to know. I know that's something that a lot of students that we get asked a lot about, and they want to make sure that they're doing the best that they can to be able to showcase their skills and to, get that job offer. And so you kind of touched on this a little bit in one of your previous answers. What should be included with each individual project that you showcase? You mentioned about linking to GitHub, having some sort of small write-up, but any like finer details?
So can you say the final thing again? So any what?
Any like, what are the finer details to make sure to include with everything?
Yeah, I mean, having a GitHub is important. I think that the other thing that I would think about, and I think that this also kind of leads into thinking of yourself as a data scientist as this kind of end-to-end person, is really showing your ability to communicate your results and to a broader audience, and really especially to a non-technical audience. One of the most important things to know as a data scientist is your primary client is not going to be a data scientist. They may not even understand data at all. They aren't looking for you to tell them, exactly what test you ran. They're looking for you to make a recommendation that makes sense to them in their language. It could be the language of marketing, of business. In my world, it's the language of medicine. And so having a presentation or a write-up that really kind of highlights your ability to not just dive into the weeds, but then to really kind of summarize those high-level findings with actionable recommendations or actionable things the person could do, I think is also pretty important. And I know now in San Francisco, many, many data scientist roles, I would say maybe 30%, maybe up to 50% are actually having candidates give some kind of talk. We have a talk at the Parker Institute. When I was applying for roles several years ago, I think it was about 50% of jobs had between a 15 and a 1 hour talk, 15 minutes and 1 hour. And so making a slide deck that really illustrates your ability to succinctly summarize, the question and the analysis you did and the data that you analyzed, and then bring it all home and show that you actually could be comfortable speaking to a CEO or a CTO or whoever, is very, very useful, and that's going to really help.
Cool. And sort of on that topic, do you have, being able to speak to the right audience with your portfolio, do you have any examples that you can share about an amazing project that you got from an application, sort of what questions that individual asked and how they answered the question for what they're trying to solve?
I can. It's kind of funny. The person I'm thinking of was someone who's actually now a colleague. And because we're a cancer research institute, the talks can sometimes be very, very scientific. So this person who was applying was speaking about the evolution of the three-spine stickleback, which is a model organism used to study evolution in animals. And this talk kind of did exactly the pieces that I've laid out, where he very, very clearly said, this is the question I'm trying to understand. I'm trying to understand the evolution of the fourth spine. I should say beforehand, none of us knew anything about what he was talking about, right? So I'm a mathematician by training. We all know a little bit of biology, but this particular candidate was like a very, very hardcore biologist, and so we didn't really know, but in his talk was able to, he was really able to kind of walk us through exactly what the question was. How did this particular spine on this fish evolve? He was able to talk us through how he collected his data. He used a special kind of sequencing that he actually helped invent to look at the DNA structure of this species of fish. He very, very clearly laid out, his analysis plan and how he was able to compare this fish to something that was very, very similar to it that didn't have this, and find the particular place in the DNA that was different, and then how he quantified that. And then he was able to kind of miraculously talk about how this had implications for the larger world of how we think about evolution, which is something that we think about a lot. Just kind of zooming out into why this particular piece of DNA had actually changed. And so, yeah, that particular project, I think that he just did a very good job of going through each of these pieces very, very clearly and helping us understand. And actually, that's kind of the consistent theme when I'm thinking back to these other talks. It's not that we understand, we typically don't understand everything they're doing, but their communication, they're extremely good at simplifying and bringing it back down to this core pattern of ask a question, find the data, then analyze the data, then conclude from the data what you learned. If you can do that well, the world is your oyster for data science, at least.
That sounds awesome. And it also kind of sounds like this person that you're referring to was able to really make the connection between the project that I worked on and demonstrating the type of value that he could bring, or he or she could bring to joining your team by, even though it wasn't anything necessarily related to cancer, but genetics.
Exactly. Yep, that's exactly true. And I think that the thing that all these projects have in common is that they're able to kind of seamlessly weave together the ability to analyze data and the ability to interpret data. And these are two skills that I think have historically been kind of divorced. I think for a long time there were data analysts, and that was a role in a company, and the data analyst would kind of get questions from above or from someone to the side, and they would say, please answer these questions for me and make a plot, and the data analyst would return that plot. And there's the interpreter, there's the person who's asking the questions and understanding what the plots mean. Someone kind of asked this question here. Mm-hmm. So I see a data scientist as really trying to merge the people who can ask the question and can interpret the plot with the person who's able to do the analysis. So it's bringing two roles that historically have been divorced into one, and the synergy that happens when you're able to, really, really do that integration tightly within one person who are able to you're just sitting in a meeting and you're like, oh, we have the data to answer that question, and this is really important to the CEO. I'll go run and make some plots. And I've actually had these experiences myself. I've been very lucky where I've been able to do that. And because you understand the data so well, you understand the types of questions that can be asked and the types of things that can, the types of results that can be provided in ways that if this was, when this knowledge was divided was very, very hard. So that's really, to me, what I see as the core skill of a data scientist and kind of one of the core things they can bring to an organization.
Great. Thank you for answering that question from the chat. I'm going to combine a couple of questions that we also got in the chat. So there are a couple folks who are asking about how they know if data science is right for them as a career move and how to get better clarity on that. They've studied a little bit within data science, or they have some programming experience and some interest in math. How would you recommend going about figuring out if it's right to go in that direction?
Yeah, absolutely. I think a couple of pieces of advice. So the first one that I would kind of, hope that people who are here could work through is try to ignore the hype. So there's lots and lots and lots of hype around data science, and people are saying it's going to solve every problem. And when you're making a decision to potentially change your career, I think it's really important to kind of really understand what a data scientist does. And so in some sense, the best way to see if it's right for you is to start playing around, start, reading tutorials and playing around with data sets and really getting very comfortable with the fact that it's, there's really, really exciting stuff with machine learning, but actually a lot of the time it's finding the data, downloading the data, cleaning the data, trying to even understand what's in the data. And if you find those types of questions as exciting to you as building a classifier or, to predict something and kind of this end-to-end life cycle of data is interesting to you, then that to me would potentially suggest that you would, enjoy the job. But there's this classic, this classic aphorism in data science that we spend 90% of our time cleaning and finding our data and 10% of our time actually analyzing it. And this is very true. And so really, really understanding that piece and diving in and feeling comfortable. And, for me, actually, I enjoy the data cleaning part. It's kind of nerdy, but it's really interesting to kind of think through why is data missing, why are certain values dirty, and how do we get them out? It's almost meditative, which is kind of weird, but and so that for me is one of the ways I knew that I really enjoyed this type of work was because the whole process remained interesting.
Thanks for sharing that anecdote. It definitely, makes the job a lot more fun and a lot more enjoyable when you actually enjoy the work that you're doing and have fun while you're doing it as well.
Yeah, absolutely.
And so how would you suggest that someone goes about getting project experience, or if they're relatively new to the field of data science, but they haven't worked in the field yet, or they're still just getting started, how can someone go about getting actual project experience, whether formally or informally?
Yeah. Well, there's Springboard, and I guess everyone on the call is probably somewhat familiar that there's this course. So I won't belabor the point. However, the other place that I like to highlight to people is most people coming into data science often, not most, but many of the ones of my mentees and people who I've known are coming at data science with a pre-existing set of expertise. So I'm thinking of one of my mentees was actually a teacher for a long, long time. He had been a high school biology teacher for many years. And so when he was trying to think through, what type of project should I do to get going, the first and most immediate type of thing that he could imagine doing was working on data related to education. And that's actually really, really useful for a couple of reasons. One, when you have pre-existing expertise, you likely already know the sources of data that are good or not, even if you yourself haven't immediately worked with them. you're like, oh, that database is the one that, my analyst or the other person would always pull from, so I know that this is the right place to go. Number two, you also probably know what questions are already interesting. So, you've been working in a particular field and you say, oh yeah, these are the questions that we're really interested in answering. If it's in teaching, we're really interested in understanding what's the dropout rate between different types of people and how can that be mitigated by the role of a teacher. Okay. And then three, you also kind of understand if the results are making sense, where, as you're kind of starting to play with this data, if you're seeing something that's like a 300% gain or a 300% reduction in student dropout based on some intervention, you would probably say, oh, there's no way that that's true. I must have made a mistake because we've tried that and it only, worked for 5% of people or something like this. And so those things, like a professional data scientist learns to be able to do that for many, many different fields, and kind of gets up to speed pretty quickly. So you learn how to ask questions about data sets and fields you've never worked in before. But in some sense, you're kind of jumping the line a little bit when you're working in a place where you already have expertise, because a lot of the things that you have to kind of learn, this soft knowledge of data science, you've already kind of dealt with, and you can really focus on how do I clean my data in pandas or in R, and how do I make the plots, and these basic types of questions that are more technical, but there's also a lot of great resources around, right? So there's great things in Data Camp about how do you actually learn pandas. There's many, many resources that are online for actually learning how to code. And then the softer part of data science, which is, in my opinion, is the harder part. For this particular project, you're able to kind of, work around as you learn about how to think like a data scientist. Hopefully that makes sense. It's a little long.
Sort of building off of that, because you had mentioned about your mentee who's coming from a teaching background, coming into data science. And so on the topic of backgrounds, how does data science differ in the field of like healthcare, for instance, as opposed to other fields? Is it preferred to, let's say, have a healthcare background if you want to be a data scientist for a healthcare type of company versus not?
Yeah, that's a really good question. From my experience, the answer is maybe, which is not the best answer, but I can kind of walk through it. So there absolutely are some types of data scientist role that require having expert knowledge, full stop. And this is true in healthcare, it's true in medicine, it's true in finance, it's true in really every place that a data scientist can imagine working. However, it doesn't mean that at those companies there are not data scientist roles for non-experts or specialists in that particular field, right? So the data scientist teams, so we do a lot in cancer, and I've talked with friends of mine who are kind of on the teams of some of these diagnostic startups, and there are some teams that are very full of experts around exactly how we're measuring the types of things in the blood that we're trying to use to predict cancer. And then there's people who are machine learning experts, or just kind of these classic end-to-end data scientists, and they have a role as well. And so I would say that if you have expert knowledge, it's always my recommendation that you try to leverage that, because that helps you stand out. But if you don't have expert knowledge, or you don't really want to work in the field that you've been working in, I don't see that inhibiting you for being able to work around or close to fields that you're interested in. So if you're from finance and you want to work in healthcare, don't let that stop you. It just means that you may be on a team that's not composed all of former cancer biologists, and that's fine, right? You'll be able to learn a lot. And one thing that's really great about data science is because everyone comes from these backgrounds of learning and education, it could be in a couple of years of being in one role at this company, you're able to osmose or learn all the information, and you can transition into a new role that is more technical and more focused on having this expert knowledge, and by then you'll have that. And I see that happen a lot in data science. Many times people come in without the expert knowledge and they leave with it, and then that's really helpful to them.
And I think that's something that's really common across not just data science, but every industry in general. Like, of course, people who are hiring managers would love if, you know,
Hmm.
you're applying and you're an expert in that particular industry.
Hmm.
It's always okay if you don't, because you can learn on the job. It allows you to stay more agile and nimble and be able to bring a
Exactly.
total outside perspective into what it is that you're doing in that role.
Hmm.
And so I'm going to go ahead and combine a couple or a few questions that we got in the chat that are
Hmm.
on the topic of background and skills. So, is there a preferred strength or recommended strength to have? So, coming from a mathematics background,
Yeah.
does that work in your favor as opposed to, you know, being a little bit stronger in statistics? Or how valuable is it to have a deep understanding of SQL and getting your first data science role?
Yeah. Absolutely. Um, so someone also alluded to this in one of the questions. Right now in data science, there are many, many different types of scientists, and there are many, many different needs. And so I would say that all backgrounds can potentially be extremely useful and far more useful than any other type of background for a particular data scientist role. And that same background could potentially put you at a disadvantage or be not quite as favorable as someone with a different background. So for example, statistics, if you're a formally trained statistician and you have a PhD in statistics, that would make you very, very good for a data scientist role where they expect that they need very careful quantification using, you know, very advanced Bayesian methods. And then they also need someone who can communicate those results to the board or whatever. However, that statistician may not have the business knowledge, business insight. They may not know SQL, and that very, very well could be required for other roles. There are absolutely data scientist jobs where SQL is the primary language that the person is using. Very, very advanced queries on, you know, large kind of Hadoop instances or something like this to pull down, you know, data in real time and get that filtered into a dashboard or something like that. So, and then in that type of role, if you're a SQL expert, that really could behoove you, and you may lose out to the person who's the healthcare expert when they're looking for someone to be able to do healthcare. So one of the things that I tell my mentees is, like, this can make looking for a data scientist role often seem kind of challenging, because you say, I don't really know what they're looking for. And you'll realize that the company sometimes doesn't actually know either. But the way that I kind of recommend to people is it's really important to just continue to take shots on goal and to really be able to define yourself, the type of data scientist you want to be. And that kind of gets back to the portfolio project type of idea. One of the things that I try to work with my mentees around is having one kind of classic portfolio project that shows your ability to go end to end with the standard skill set. But as possible, I usually try to work with my mentees for their second project to have something that really speaks to their particular strengths, if that's, you know, from business or healthcare or statistics or whatever, because then that project can be the thing that really helps you be the unicorn that they're looking for, right? And being the unicorn is often exactly what you want to be. The way that we talk about it when you're looking for a job is you'd rather be first on someone's list, you know, 1 out of 100 times than be third on people's list 99 out of 100 times or something, right? It's much better to be, you know, slightly special and slightly unique, because you're going to be able to find your niche. It just may take some time as you're looking.
Great, thank you. So we're just going to take a couple more questions here to be sensitive for everyone's time joining us today. So one of the ones that we got here in the chat was, do you have any book suggestions for learning data science, or anything that would be helpful for someone just getting started?
Yeah, so books. I guess there's a couple of things I'll say. So one, you know, speaking very truthfully, when I was kind of getting up and going, so my background is that I was in academia. I was a research scientist at UC Berkeley, and I decided to make the transition. And I did have holes in my knowledge to fill as well. And I filled those primarily with online tools. At the time, I think Data Camp was just getting up and going. There were some other things like Code Academy, and I really, really liked these a lot because they give you practical knowledge. So if you're thinking of kind of diving into data science, I really encourage you to work practically and start coding. It's typically the coding piece that a lot of students are saying, oh, I have the statistics training or I have the whatever, but it's the coding. Yeah, but there are some books. So the most classic and most important book in the field, in my opinion, is kind of an introduction. If you have some math background, you would definitely want to have, taken like calculus and maybe linear algebra or like basic statistics. It's called Introduction to Statistical Learning by Rob Tibshirani and Trevor Hasty and a couple other colleagues. This book really forms the core for an introduction to the modern way that we think about machine learning in a statistical context. It's beautifully written, and it's written at about an undergraduate level. The other book that actually really helped me is the books about R written by Hadley Wickham. Hadley is the person who's invented the tidyverse, which is kind of one of the de facto standards for R. And even if you don't use R, I myself kind of move between both. But even if you don't use R, Hadley thinks about data in the right way that will really help you think, how should I have my data structured and cleaned, and how should I think about visualization? So reading his books actually helped my Python data science tremendously, much less my R. So I really recommend the books from Hadley as well.
Awesome. Thank you for sharing those recommendations. And one question, our last question that I'll take from the chat actually hits on a point that you just mentioned about using R or shifting away from R in Python. Is there what is the recommended language within data science? I know it's a question that gets asked a lot. So
yeah, this is a topic that a lot of people have a lot of opinions about. I can tell you at the Parker Institute, we do not test ever for a particular language. We've had people do, we do have a technical interview process. We've had people do that technical in Python and R, both. SQL, someone did it in C once, which was really interesting. We've actually seen someone do it, I think, in Perl as well. So we've seen all sorts of things, and actually we're totally fine with that, even if my Perl is a lot weaker than my R, but we're really looking for how you think about coding and if you're able to kind of get the basic structure together. And I think that rule is generally true across most of tech companies, and certainly with Python and R. I've never ever seen it happen that one of my mentees who's proficient in Python goes into a place that primarily uses R, and that was like a big problem. I think the most that they've ever said is, great, here's your offer, we're excited for you to join. Please, in the next 3 weeks as you're transitioning, start practicing R, and here are some good books to read, and maybe do the data camp in R and whatever. I learned R maybe a couple of years ago when my team transitioned, and it took some time. It's never completely easy, but now I feel very comfortable in both. And you find that both have kind of their uses and places where you don't want to use them. So I wouldn't worry about it. I think Python's a great starting language. If you're already using R, that's great too. And really don't focus, perhaps most importantly, if you're already really good at one and you want to move into data science, I would say don't have the first thing you do be to go learn the other. I would focus on learning the machine learning and the statistics and the presentations and all of these other skills. Those are going to take you a lot farther than not having those, but being really good at the other language.
Awesome. Thank you for sharing your insights on that. It's always fun to hear what people have to say about Python versus R. So one last thing before we go ahead and jump off here. We got a couple questions about Springboard and, how you can work with a mentor. So I'll share a little bit about our data science career track as well as our data science career track prep course. So for our data science career track, it's totally designed to be online and self-paced, and you get matched one-on-one with a data science mentor, someone like Danny, or could even be Danny, in a future cohort based off of what your learning goals are and what you're hoping to accomplish. And so This course, it's about 6 to 8 months, and it's for people who are comfortable with the basic probability and stats and have at least 6 months of active coding experience. And so this program, like all of our Springboard courses, was totally designed to not only give students the theoretical knowledge of, data science or, one of the other topics for our courses, but also to give students a hands-on learning and experience. And so students get to work through a few capstone projects throughout the course, and we'll work with their mentor on them to make sure that they're going through the right steps and processes for cleaning the data, for organizing everything, for displaying it in a meaningful way, and even being able to share meaningful insights to folks. So I'll go ahead and share the link for that course over in the chat, along with a link for our data science career track prep course, which it's our introductory course that gives you the foundational Python and statistics skills to be able to move on to the career track, or to just build a foundation with data science skills. So I'll share those, and I'll also share them as a follow-up as well. And then a couple folks also asked about links to the books that you shared about, Danny. So I'll grab those links from you after we hop off of this webinar, and also be sure to share those out with everyone as a part of the follow-up from today. And so I wanted to go ahead and thank everyone here for joining us this morning or afternoon, wherever you're joining us from. And a huge thank you to you, Danny, for taking the time out of your day to share about, building a data science portfolio, and even going a little bit more general into being a data scientist and how to get into the field or backgrounds to have. So thank you.
Yeah, thank you for having me. It was a pleasure.
Great. Well, thanks everyone for joining. Cool.